Greetings, everyone, and thank you so much for joining today's webinar. Today, we are going to be discussing Antennas 101, how to choose and use the right antenna for the job. But before we get into that, just a few items of housekeeping. This webinar is being recorded and will be available for on-demand viewing. Usually takes us about a week or so to get it edited, so please be patient. But once it's ready, it will be available for viewing at shure.com/webinars. That address again is shure.com/webinars. It's a great place where you can go to see all of our past webinars and see any upcoming webinars we have. So shure.com/webinars. And then second of all, as we go through the session today, if you have any questions, please feel free to type those in the Q&A section. We will hold on questions to the end, but type them in. We'd love to hear what you'd like to learn more about. So type in those questions and we'll answer them at the end of the session. All right, so now let's get into the presentation. Today we are joined by Mr. Jim Allen. Jim Allen is an applications engineer here at Shure. He has over 10 years of experience in live sound, and he's also a pretty funny and cool guy, if I do say so myself. Jim, I'm going to throw it over to you. Take it away.
All right. Hey, thanks for that. Okay, so we have a lot to talk about and not enough time to do it like normal. Let's just go over what we're going to talk about. First, we're going to cover the physics behind the antennas briefly. We're going to go over basic antenna types that you've probably seen or used or are interested in using. We're going to look at some not so common antenna types. We're going to talk a little bit about positioning and best practices. So if you do decide you choose one of the antennas we talk about today, you have an idea of how to use it the best, And then we'll go over some examples and then hopefully have time for questions at the end. All right, so we got a poll here, and I want you guys to answer. What best describes your experience working with antennas? And you can select one. So you have like whatever comes in the box with the receiver. If you purchased one, you have multiple receivers and they're all using their own antennas. You have remote mount antennas. Let's say maybe you have a distribution system and you have two antennas up on a wall or up on a mic stand or something. Or you kind of have a mixture of options depending on the event you're doing and the setup. Because we always say it depends a lot. So sometimes it's good to have a versatile setup.
So answers are starting to come in. We're at about 30% of the vote, so we'll let it go a few more minutes. I know that I am guilty of number one. I think we're doing this webinar specifically for me. We were discussing it beforehand, and my personal rack is quite a few of the what not to do. So I will be learning along with all of you today.
Yeah, we have a picture of Cheryl's rack in here just so we can
no, you don't.
point out what not to do.
You don't have a picture of my specific rack, but when we get to the one that is similar to mine, I will fess up. All right, it looks like we're at just over 78% of the vote. So I think that's a pretty good response rate. I'm going to end this poll and we'll take a look at what people are saying. Okay, share results. Hold on. There we go. So here are the results. A lot of people tend. Yeah, it seems like we have a lot of people that are doing a mixture. So I think we might have some people. Yeah.
Definitely. Okay, cool. So we have some experienced users. That's what I would take from this poll for sure. You use whatever comes in the box, of course. I mean, if you are new to a wireless microphone system and you haven't seen any of our webinars or anything, so that's totally understandable, especially if you just have like one receiver on the side of the stage. There might not be a reason to go any more than that,
Mm-hmm.
Yeah.
All right. I'm going to close this poll and get back to our presentation.
Cool. Thanks for answering that, you guys. Okay, so let's take a look at the physics. All right, so we have what is an antenna? It seems really simple, and I think it's something we take for granted all the time. It's just, it's just a little wire, right? It's actually a really cool wire, and it blows my mind all the time. The more I think about it, is what you can accomplish with it. So it's a transducer, kind of like a microphone, but it takes electric signals and converts them to electromagnetic waves if it's a transmitting antenna that you would find on like an IEM system, or it goes the other way. It'll take an electromagnetic wave and convert it to an electrical signal. It's not like a microphone where it needs a medium to propagate on. It just goes through the vacuum of space. If we go to the next slide, we'll kind of take a look at where you would see antennas and things like that. So we have antennas are for transmitting, they're for receiving. You find them on IEM transmitter, whether it's remote mounted or mounted directly to the transmitter itself. You find them on body pack transmitters. They're kind of hidden. I had one here. They're kind of hidden on handheld microphones. You don't always know that it's built into this little part on the bottom here, so it's not as obvious as a body pack transmitter. And then our receivers, most of them will have removable antennas, and some of the systems will come with quarter wave or half wave antennas. Some of them don't come with antennas at all, and it's up to you to choose what to use. So there's just a bunch of different ones, and they just keep in mind, a lot of them, if they're passive, can receive or transmit with the same exact antenna. All right, so let's take a look at the next one. A lot of you have probably seen this slide. So electromagnetic waves are pretty wild. They are made up of an electric field and a magnetic field that run perpendicular to each other. And the electric field is the portion that we focus on. It pretty much determines the polarity of our antennas. So you'd want that parallel. So if your antenna is vertical, basically the electric field would also be vertical. So you would want your receiving antenna vertical. And they travel at the speed of light. That's the wild part about this is electromagnetic radiation is basically the same for radio waves as it is light waves. Light waves are just much higher frequency and they go really fast. Sometimes you think, hey, how long does it take? Is there any latency involved with the wireless system? How long does it take to go from the transmitter to the receiver? That part of it, not really that's perceptible to humans just because it's the speed of light. It is extremely fast, 186,000 miles per second. And that just is wild to me. And it's just like, it's similar to, sorry, I'm messing up here. So unlike microphones, they don't need a medium to propagate. They travel through the vacuum of space most efficiently. And they are polarized, like I said a minute ago, and we'll look at that further. And it's just pretty wild. All right, let's keep moving here, and we have some really cool videos here. Hopefully that's working. Okay, cool. So what you see here is a UA860. We did some measurements, and we have a really good visual of what's happening when you are transmitting. It looks similar transmitting or receiving, but basically, with a dipole, the way it works is you send a signal to the dipole from the middle and it feeds outwards, and there's a positive charge, let's say it's on the top, and a negative charge on the bottom of it, and then they move and swap places. And then they do that alternating, like an alternating current basically. And when that happens, it creates a current across the surface of the antenna, and that creates or generates a magnetic field around it. And with individuals like Maxwell came up with, if there's any variation in the magnetic field, there's going to be a variation in the electric field. So it basically creates that magnetic field around the antenna, which generates an electric field out from that, and it propagates away from the antenna. And that's pretty wild thinking about that and how it works, because you don't see it. It doesn't look like anything's happening unless you have really awesome measurement equipment like we have here. So I'll just read this real quick. As it moves back and forth on the surface of the antenna, the current waves are launched outwards in all directions at the speed of light without any medium to propagate. It's really cool. And this is a half wave dipole, what we see right here. On the next slide is a similar animation that shows how like a log periodic dipole array works, or, I mean, you've seen these antennas. I'll talk about them further in a minute. But it's a series of dipoles. It's an array of dipoles lined up in a certain way. And you can see which part of the antenna is more used is based on what frequency is used. And they're really wide band. There's much smaller elements at the front of the antenna and much larger elements at the rear, so we can cover a really large range of frequencies with the way that's set up. And you can see the 470 megahertz video on the top left, it's using the much larger elements, versus the 1000 megahertz are using the very small elements in the front. The wavelength basically determines the size of the antenna. So with a lot of our wireless systems, they're in the UHF TV band. So it's like 470 megahertz to 616 megahertz after the auction happened. So where was I going with that? Sorry about that. They are all a consistent length, I guess. If hold on here, I'm messing up. Sorry, everybody. I'm nervous. So the wavelength compared to VHF frequencies, the wavelength is much smaller in the UHF frequencies. So the VHF frequencies, we'll look at some VHF antennas. They're much larger. Okay, sorry about that. Next, we have polarization. So like I mentioned, the electric field is going to be oriented depending on how our antennas are oriented. So if we have a half wave antenna oriented vertically, then our wave, the electric field of the electromagnetic wave, is going to propagate vertically. So in that case, we would want our receive antenna to also be vertical, or else we'll lose a bit there. If we were in a vacuum of space, we would get almost nothing from a horizontally oriented antenna when our transmit antenna is oriented vertically. But we have reflections and things that kind of shift the polarity of which helps us out in that aspect of it. So you'll never get a complete drop, but it is possible to get pretty close to it. Let me see if I missed anything here. All right. And next we have, did that animation work there on that last one, Cheryl? Sorry. Okay, cool.
Yep,
So
I
let's
think so.
go to, oh, sorry.
Sorry, I'm having a little bit of presentation blips as well. So there we go. I think we're working now.
Okay. So that was linear polarization. Most of our antennas are polarized linearly, like our UA8s, our dipole antennas, even the log periodic, the LPDAs, like the UA874, the PA805, are all linearly polarized antennas. The helical kind of takes care of a polarization where it's circularly polarized the way it's designed. And you can use a helical antenna with a vertically polarized antenna or a linearly polarized antenna, no problem. It just really helps, like, let's say if you are using in-ear monitors, these are typically passive. So with a helical antenna, if you have it transmitting from your combiner or a transmitter on the side of the stage, or even from front of house, it helps a lot to have it circularly polarized, because then if you're wearing a body pack and you're doing anything where you're not just standing there completely vertical, you won't have to worry about it as much because it circularly polarizes the wave. And you can kind of see that in the animations there. So no matter which way the antenna that you're receiving with is oriented, you still get really good reception because the wave itself is circularly polarized. There are different types of helicals. There's left-hand wound and right-hand wound. So if you're selecting helicals, just make sure that they are both the same. And then these can be used, because they're passive, they can be used for transmit or receive antennas. And let's say you have somebody breakdancing on stage with a microphone and they, the linearity is all over the place. If they're using like a body pack or something, you don't have to worry about it with helical antennas on the receive end. And if they're also wearing an in-ear pack, then you can have a helical on the transmit end as well. Sometimes folks will have a right wound helical for transmit, and then the left hand wound for receive, which it helps, so you don't have to worry about them. It kind of helps with rejection. So let's see here if I missed anything. Now, one thing I forgot to mention, when we get into these directional antennas like the LPDA, when we talk about the directionality of these antennas and gain, there's a trade-off between how directional antenna is and how much gain there is, and we'll cover that here in the type section. So I'm jumping ahead. Sorry about that. Okay, so hopefully everyone's good with that. Helicals are great. If you've ever gone to a large event, you'll probably see mostly helicals and the LPDAs on the side of the stage, but it's not always necessary. It might just be what they have in the case. So let's go forward. Okay, so let's look at a survey of our antennas. And you can see we have the half wave dipole on the left. That's like a UA8 there. Those are a little bit more narrow band. So if you're covering just a single frequency band in your rack of gear, you should be good with that. But if you're trying to cover a wide range of frequencies, you have multiple receivers in different frequency bands, then that's when you would go up to the UA860 because it's much more consistent across that wide range of frequencies. And then we go to the UA860, which is a sorry here, that would be a UA864 in the center there. The ceiling mount antenna is a directional antenna, and it's really good when you don't want to see the antennas. Like let's think in a conference room mounted to the ceiling or the wall, they're paintable. And as we go to the right here, we get more directional. The next we have basically the same antenna in two different form factors. One is the PA805 SWB, it's a LPDA, but it's passive. So you could use that for in-ears or wireless microphones. And the UA874 is active. There's a little amplifier on there that allows you to use it for receive only. And I'll cover that more. And then those are pretty directional. So those are really good for front of house and things like that. And then we jump up to the helical, which is the circularly polarized. And there's a few different versions of that, depending on whether you need them to be more durable, or take up less space. They're all pretty similar, but we'll take a look further into those. Okay, let's move along here. One thing I did not talk about is what happens if we get a receiver and there are no external antennas. You're looking in the box, there's no antennas. You're looking at the receiver, where do they connect to? We have a few receivers, BLX4 and the BLX88 are tabletop receivers that have built-in antennas. So it makes it really easy. There's no way to really expand these antenna systems. So if you are looking at this type of system, they're really good for easy, clean setup. They're nice to look at. You can sit them right on a table and get good coverage as long as you always have line of sight and they're nearby. If you wouldn't want to use these at front of house, buried underneath a soundboard and a rack surrounded by metal without any way to remote mount the antennas. So if you're going to have them on the side of the stage or you have a nice shelf to place them up on, they work really well. There's education facilities will have them like on the side of the room, maybe on the desk near where the audio input would be, which is perfect. And they work great for that because then you don't even have to think about antennas. It's just a few things to think about when you're using this. Antennas we'll look at more. You don't want to put them near other antennas or other metal objects. So obviously you wouldn't want to stack these up on top of each other. You want to separate them by space. So if you did have a rack on the side of the stage, we have little rack trays, but I wouldn't just stack them, rack U by rack U by rack U. I would put space in between them. Or if they're on the side of let's say you have a series of shelves, you would put them side by side with like a wavelength between them, or you could have a series of shelves vertically if you have a lot of these receiver. Obviously, if you're making a system with a high channel count, you wouldn't want to go with something like this because it's really difficult to get, 12 channels of BLX all within line of sight without a shelving system on the side of the room. All right, so those are built-in antennas. Just be careful with those as far as stacking them and putting them near other metal sources. Okay, next we have the quarter wave. Now this is like a half wave dipole, but it's a quarter of the wavelength versus a half of the wavelength. And it works by using a ground plane to come up. The reflections create like a mirror image of the other side of the dipole using a ground plane. And they have good gain. They're not perfectly omnidirectional, but mostly omnidirectional. It's more like a donut shape, similar to the dipole. And they come with a lot of our wireless systems like BLX, SLXD, PSM 300, and they work great. Again, as long as you have line of sight, You can use these on mounted right to the back of the receiver. You wouldn't want them inside of a rack on the back of the receiver surrounded by metal. But there's usually hardware to bring them around to the front of the receiver, and that works really well because that helps you get line of sight. And usually with these systems like the BLX4R you see there, or the SLX-D receivers, you can use an antenna distribution system to combine a bunch of these basically and have them all run off of just 2 antennas. And you can use quarter wave, just make sure all your systems are in a similar frequency band, because like the UA8, these have a narrower range of frequencies they cover. And yeah, it says 360-degree beam width, but it's more like a half donut. And we have some patterns here coming up, and they are vertically polarized, assuming the antenna is vertically oriented. Cool. There's some other ones and some things to think about. I already covered these, but always maintain line of sight. This goes for all of our wireless systems. You don't want metal objects or anything in between LED walls, things that would, or even human bodies, you would want to prevent getting those in between your antennas and your transmitter. The quarter waves also, you don't want to remote mount these. Like with a half wave antenna, you have a dipole and you don't rely on a ground plane to get really good reception. So you wouldn't want to just mount these with a BNC coupler on the end of a coax cable or something like that. That's really going to impact your reception negatively. So use a half wave if you want to remote mount them always. And they can be, just like any of our passive antennas, they can be used for transmitters or receivers. And you can see our QLXD system comes with a removable quarter wave that mounts directly to the transmitter. And the UA400B you see there is what is included with a lot of our wireless systems. And they work really well as long as you follow, these guidelines. Okay, let's keep going here. Okay, so when I said half donut earlier, you can see that here. Assume that antenna is right in the middle of that plot you see there. And that gives you a good idea of how the pickup coverage is. So vertically, I'm pretty much covered around this 360 degrees, but if I put it like this, I'm not really covered very much at all. There's not a lot there. If the transmitter was directly in front of me, there's not a lot there, for the signal to go. So if you look, you just make sure that when you're using these that they are oriented similar to how the antenna that's transmitting is oriented. Another thing I think I touched on a second ago, sorry about that, is the bandwidth of these antennas. The UA8 itself is really good. It has a pretty wide bandwidth, but if you're trying to cover wideband like 470 to 616 or something similar to that, then I'd probably jump up to the UA860 versus just the UA8. And these are included with like the PSM 900 system, PSM 1000, ULXD, QLXD, and they work really well. You can remote mount them because they are a half wave dipole versus a quarter wave. Okay, and because, I won't go into this too much, but because they are not perfectly omnidirectional like an isotropic antenna, there is a little bit of gain. You're probably about 2 dB of gain because you trade off omnidirectionality, I guess, for gain. So the more directional antenna is, the more gain you're going to have. Forward gain here. Okay, we can move on. Sorry. Look at that time just getting away from me here. Okay, so this is the UA860. It's a half-wave dipole just like the UA8, but this is much more consistent as far as its coverage across wider frequencies. So I think this goes from 470 up to 960 megahertz. And it's really consistent. That pattern that you see there is really consistent across the whole frequency range versus the UA8 would be a little less consistent the further away you get from the range stated by it on the antenna. And you can usually see if you look on the UA8s themselves, they say right down here, you probably can't see that, but they'll tell you what range of frequencies they're meant to cover. Okay, so UA860, again, with these half-wave omnidirectional antennas, they're really good if you're, let's say you're on the side of the stage with your equipment, or you're trying to cover a really wide area where the mic or transmitter could go anywhere, or even if you were using it for in-ear monitors, the receiving pack are going anywhere around the antenna. They're perfect for that. But we might want to look at a more directional antenna if the equipment's going to be out at front of house or 50 feet or more away, and we want to avoid a lot of multipath reflections that can impact our signal. So let's go on to the directional antennas. Thank you. And here you see both of these antennas are very similar. They're pretty much the same antenna, just one is active, the UA874. There's a little amplifier built in that has makeup gain for the sole purpose of that amplifier is to make up for loss over longer antenna cable runs. So if you are trying to decide between the UA874 and the PA805, and you know that this is going to be a permanent installation at front of house, and the coax cable is going to be maybe 10 foot to 25 foot long tops, you probably don't need the UA874. You could get away with the PA805 just fine. You don't need that amplifier. You'll probably end up putting it. There's a little switch that lets you impact how much amplification happens, and there's a 0 setting and a -6 setting. So if you're using a short cable with these, you're probably going to put it on -6 anyways to avoid overloading all of your wireless receivers. So if you are at front of house, or you need to put these somewhere where you need a long antenna cable run, UA874, perfect for that. Also, let's say you're a rental house or something and you need a really versatile antenna that can be placed pretty much anywhere, regardless of how long the antenna cable run is. That would work well, but just keep in mind it's for receivers only. You can't use an active antenna or active antenna amplifier on an in-ear monitoring system. So if it was in-ear monitoring system, obviously go with the PA805, or if you're using a shorter cable run, PA805 would be just fine. It would work well. And as you can see, they are directional. I think it's about 120 degrees they pick up. So anything that comes from the sides or from behind, like reflections or any interference sources, they reject that really well. And so you can use that to your advantage in a lot of situations, especially if you have in-ear monitor antennas and receiving antennas. So you can use the directionality of these to focus your in-ear monitor energy away from your receiving antennas, or if you knew there was an interference source like in-ear monitors or even a TV tower right down the street, you could put the antenna facing away from that to reject that unwanted interference. Okay, next. This one is it's really good as a low profile option. So if you or a client or somebody does not like looking at antennas, these are a good option, and they work really well to cover large areas if you're mounting them on a higher ceiling, or if you need to cover a specific area, you can put them on the side of a wall. But just keep in mind, if they're on a wall facing one direction, you won't be able to go too far either side. They have like a half cardioid pattern that makes them pretty wide, but they are directional. So keep that in mind, especially if you're going to mount it on a ceiling or up really high up on a wall. In those instances, be careful with this one, because you could just put your performance area or the area where the microphone will be out of the coverage zone. And these, like the UA874, are active. There is a little amplifier built in, and it's used specifically for makeup gain. So these would not work for in-ear monitors. Let me see if I'm missing anything. No, we're good. Yeah, and that's the UA864. I believe it can be painted too. So if you don't like the color it comes in, or it would fit with your room better, you can paint it. Just make sure you don't use any like metallic paint or anything with any kind of metallic substance in it. Okay. What do we got next? We have the Helical. This is the HA8089. You've probably seen these at a lot of events. I used these quite a bit in a previous life. They work really well for receive antennas and transmit antennas, but they are much more directional than the UA874 or the PA805. You get the benefit of having the circular polar pattern, the circular electromagnetic wave, but it is much more directional than the PA805 or UA874. So keep that in mind when positioning these. And because they're more directional, they end up having a bit higher gain, especially on the receive end. You wouldn't want these right next to a transmitter. When you're using it for in-ear monitors, it focuses the energy in a way where you can pinpoint your coverage area much better, and it will help with reception because it focuses that energy towards that. It will be, I guess you could say, more spectrally dense in the area where your receiver pack is. So it helps with that, along with being circularly polarized. And that's the HA89. So it's a really good antenna. Some folks don't like the way they look, but they are transparent, so it helps a bit. You'll need a beefier mic stand if you're going to put these up high, so keep that in mind. But other than that, performance-wise, they work fantastic. And they're wideband like the UA874 and PA805, so you can cover a wide range of frequencies with these. Okay, what do we got next here? We have a similar helical antenna. This is also a helical, but it's a domed helical. It's not quite as long as the 89, the HA8089. The HA8091 has a protective cover on it, basically, so it's going to be more durable. You would want to be very careful with these. You don't want to break any of these or have anyone put anything inside where the coil is, or that you just want to be very careful with these. So having the HA8091, if you are on the road and you need to throw it in a case or somewhere, and this might be a good way to go. Really good for in-ear monitors, but it is not transparent. So it's going to be a little more, if you're used to working with the creative types, they're not going to really like this antenna as much as some other ones that can be hidden. So just keep that in mind. And then there's the HA4540, which is essentially the exact same antenna. It just does not have the protective dome. And these are circularly polarized, and you can see the coverage zone of these compared to the 8089. They're going to be a little less directional. So these are about 72 degrees. The 8089 is about 63 degrees. So less directional, a little bit more forgiving as far as placement goes and where your coverage area is going to be. But they work really well for in-ear monitors. They work really well for wireless microphones, and you could put these at front of house or the side of the stage. But just keep in mind, if it's a small stage and you have this right next to somebody who's using in-ear monitor pack or a wireless transmitter, you just keep that in mind. It might not be the best way to go just because of how directional they are, especially if you're trying to pick up a wider area. Hopefully that makes sense. All right, what do we got next here? So I think I covered on the next slide active and passive antennas. The most important part about this is when you're using active, more gain is not better. Okay, more gain can cause more problems than it can help if you're not using it correctly, as in it is specifically to compensate for loss over longer antenna cable runs, especially if you have like a more lossy cable, a long run of RG58, that amplifier is probably going to save the day. But if you're using a really short run of RG8, that's something that's not really lossy at all, the directionality coupled with the amplifier can really wreak havoc and impact your range on your microphones. And depending on the wireless system, there's little overload warnings or LEDs that'll pop up and, let you know that something's not right. So just keep that in mind when you're using active antennas, and they are only for wireless microphones. They cannot be used for in-ear monitors. And then passive are reciprocal. You can use them for in-ear monitors or as a transmit antenna or a receive antenna. Yeah, and then let's see here. And for all of them, always maintain line of sight. It's hard to say that because we're not talking about your eyes, because light waves are much smaller wavelength and can get through a lot more obstacles than what these radio waves are. So an obstacle, I guess you just have to think about that. Like you can see through a chain link fence. So if you have your antennas on one side and your microphone on the other, although you can see through that chain link fence, if it's metal, the radio wave is a much larger wavelength than the holes in the chain link fence. So it'll basically just reflect it and you'll have a hard time. Ask anybody who's worked at a baseball field where they have a kiosk with a receiver in the center and they try to have the umpire go out to the mound to, you know, announce things. So it's just like you got to be careful with that. So line of sight is always important. Just if you can see it, cool. Make sure there's not a chain link fence or something like that that could obstruct it. And also human bodies are very absorbent and can also, you know, reduce range or even cause dropouts. So if you are very important, if you are, let's say, if everything's at front of house, you want it above head height for either of these types of antennas, just line of sight's really key. And it seems to be something that pops up a lot when it comes to troubleshooting issues. Okay, and then active versus passive, I think we're good there. Let's look at some more antenna types because I'm already losing time here. Okay, so now we have these antennas. We have the UA860V. Now you see that whip on there, it looks exactly like one of these, which is a half-wave dipole. That is not. That is a quarter wave, a VHF wave, and that plate is that ground plane I was talking about, so you can remote mount these for VHF frequency because the wavelength is much larger, so the antenna needs to be much larger. And the UA874V, I mean, that antenna looks really cool, but keep in mind it's a little over 2 feet tall. So if you had these at front of house, they're going to be seen, and you wouldn't want these on the side of the stage, especially if they're blocking lights or something that could, you know, visually they're not the nicest antennas, but they do have benefits. There's the lower cable losses and better path loss. The dropout zones are larger for VHF, but there's a higher RF noise floor in many places. So if you are selecting, obviously if you have a VHF system, you're going to select VHF antennas. But I guess this would come down to make sure VHF wireless system is the way you want to go in this case. So those are VHF. That is a quarter wave mounted to a ground plane, so we can remote mount the UA860V, and that is a log periodic dipole array for the UA874. It's just massive because it has to be, because the wavelength is proportional to the antenna is proportional to the wavelength of the frequency we're transmitting or receiving on. Okay, let's look at some more oddballs. So here we have the PA805Z2. Now it's hard to tell. It looks just like the UA874 or PA805, the bigger one. This one's very small. It's for 2.4 gigahertz. So is the AXT644. There's benefits for these, but this is again like VHF. These are more specific to 2.4 gigahertz systems for the PA805Z2, like GLXD Advanced. And then the AXT644 is specifically made for our ShowLink remote control systems for Axient Digital and getting coverage when they're connected to our ShowLink remote control access point, the AD610. 2.4 gigahertz is very noisy because everybody uses it for everything these days. The noise floor is raised and things are just hopping around everywhere. So the antenna you use is very important for picking these up, especially for like GLXD. So if you have one of those systems, you probably, especially if you're going for further distance, you want to look into something like that. Okay, and those are 2.4 gigahertz antennas. Again, it's hard to visualize this unless you've seen one, but the PA805Z2 is absolutely adorable because it's so small. Okay. Part 4, let's look at best practices. So in theory, you should only need 3 antennas on the stage or anywhere at one time. 2 for your diversity receive setup. All of our wireless systems use diversity for reception to help with multipath reflections. So there's an A and a B. And then 1 for your transmit antenna if you have wireless in your monitor systems. I'm just realizing if you have wireless comm or something like that, you might have a couple more. But as far as in-ear monitors and wireless microphones are concerned, you want to consolidate that as much as possible through antenna distribution and combiners for in-ear monitors. All right, let's keep going here. All right, so we have some more. This goes back to polarization. The next slide. Oh, sorry about the animations there, Cheryl. Cool, thank you. The antenna orientation, this is a nice visual for how you can kind of get around. If you don't have helical antennas, you can basically put 2 of your dipoles or omnidirectional antennas 90 degrees from each other. So no matter which way that transmit antenna is oriented, you're still going to have decent pickup versus having them both vertical. Because if they're both vertical, you're A and B, and then your transmit antenna goes horizontal, it's going to, both your A and B are not going to have much ability to compensate for that. So having them oriented like the 90 degrees you see there, it's funny because if you ever had a TV, your antennas on top of your TV, back in my day, we had antennas on our TV, and if you put them in the bunny ears, you would get it would get the best reception, and that's pretty much why right there. Reflections can cause the polarization to shift, and that usually compensates for that. So let me see if I am missing anything here. I think we're good. But yeah, so just if you have 2 omnidirectional antennas, just put them 90 degrees from each other. You can do them both at 45. That should work just fine. You could do 1 vertical and 1 completely horizontal, depending on how things are. It depends with pretty much everything here, but that will help. Where are we at here? Okay, we're doing okay. Next thing that's very important, the transmitter to receive antenna spacing. So if you don't want to get too close, just like with in your monitors, the transmitter too close to the antenna can have a negative impact on your reception. It can overload the front end of your receivers. It can basically reduce your range and things like that. So just be careful. Or so some of our transmitters you can compensate. There will be a menu option where you can go in and adjust the RF output power. And that really helps if you have, let's say you have a guitar player stage left and they're always right next to the antennas, if that's where they are. Cool. They probably don't need it at 100 milliwatts. You could crank that down depending on which system you have. Same thing the other way around. Let's say you have a transmit antenna for IEMs and somebody's standing right next to it with their pack. The transmitter that is transmitting to their receiver, some of our systems, PSM 900 and PSM 1000, you can adjust the RF output to basically compensate for having someone really close to it. So just keep that in mind. 10 feet's always best. Obviously, it's not always going to be feasible depending on the side of your stage and where equipment can go, but these are best practices, not you have to do this or it's not going to work. Okay. Same thing with in-ear monitors. Use directional antennas to your advantage. That helps a lot, but still try to keep space between the transmit antenna and the receive antenna, Cheryl, and you should be good. Obviously, in this setup, you have 2 directional antennas for receive and a helical, which is directional for transmit. That's great because that focuses the transmit energy away from your receive antennas. You can use the directionality of the receive antennas to basically ignore the anything coming from an in-ear monitor transmitter, or even like a wireless comm system that might have a transmitting base nearby. Okay. And then in this, it's also showing, the transmit antenna. I don't know if it's as obvious, is if it was on the side of the stage, it would be more on stage than the receive antennas. which pretty much, obviously, just like I said, it's going to focus the energy away from the antenna, and nothing's going to, transmit behind it to where the receive antennas are. And that helps us there. Okay. Next one's really important because this happens a lot. Avoid parallel surfaces, especially metal ones. So if you're mounting antennas and you're selecting like a half wave omnidirectional antenna like you see here, don't mount it right on the wall unless you know that there's not metal studs in that wall, because that can impact it. And also, don't stack your wireless systems up and just put all the antennas stacked right on top of each other, creating an antenna farm, which you see here, because that can really impact your reception in a negative way. It might work, but I would challenge you to set the antennas up separated and see what kind of range you can get versus having them all stacked up in a pile of antennas like you see here. And we see it all the time, and it's just try to avoid that if you can. Okay, next slide. Place antennas above obstacles, human bodies, metal, anything. The higher you can get that antenna, the better. Always above head height, especially if everything's out at front of house. If you can get it mounted to the ceiling, that's fine. But if you have to use a super long antenna cable run to do that, it might not be as efficient as just having a short antenna cable run to the antenna just up above head height on the other side of the room, because the loss in that long cable run might have more of an impact than the distance between the transmitter and the antenna itself. And then what do we got here? Body attenuation. You've probably seen this slide if you watch our webinars, but it is important. The transmit antenna on a lot of our transmitters, a quarter wave, and as soon as you put that up against the body, we're made of salt water, basically, and we are really good at absorbing these frequencies. So you always would want, let's say if I put it in my pocket right here, that would be cool if the receive antennas are out at front of house, but if the receive antennas are behind me, I'm going to absorb a lot of that energy, and my range might not be as good, my reception might not be as good. And you can kind of get around that by just making sure the antenna doesn't get pressed right up against your body if that's possible. But just keep in mind, this will have an impact, and a lot of you may have you'll discover that your body pack transmitters don't work as well as your handheld transmitters, and this is most likely why. Handheld transmitters are usually on a mic stand, up high, versus the body pack might be clipped at your waist or in a pocket or just wherever with the antenna all folded up and things like that. And that's usually why. So just keep that in mind. Next, we have going back to our RF overload. Keep your antennas, if possible, or orient them away, so especially if they're directional, that they're oriented away from a high RF power source like a radio. So if you have security, make sure the security team knows that they should not go near your setup in the middle of an event if possible and key their radio, because those things put out an extremely powerful signal compared to our wireless body pack transmitters in your monitor systems, just because of what we're allowed to use in as far as signal strength goes without a license in the UHF TV band is different from what these devices can use in wherever they're tuned. So they can really wreak havoc. And if you've ever seen a rack on the side of the stage with a bunch of receivers in it and somebody keys a radio near an antenna, it'll just light everything up. And that's what's happening. So just keep that in mind. And then also, aside from obviously other microphones or other inner monitoring systems, keep in mind when you're positioning your antennas to not put them near LED panels if possible. A lot of LED panels emit a ton of noise that can just essentially raise your noise floor and make it a lot more difficult to find a clean frequency. Wireless intercom systems are, if they operate in the UHF TV band, are typically very powerful. Some of them will output 250 milliwatts, which is much more powerful than what you would expect to see at the receiving end of your wireless microphones. Digital TV antennas and other, like if there was a TV tower nearby, Obviously, that's going to be very powerful, much more powerful than anything we make. So if you have directional antennas, that would be a good reason to get a directional antenna and orient it away from a interference source like that. And then obviously other wireless systems. Okay, one thing I want to touch on real quick. Try not to rush too much here. This is a common question. How many systems can I get on one pair of antennas? And I'm not going to jump too deep into antenna distribution, but you can put quite a few systems on just 2 antennas. As long as the antennas themselves cover the range of frequencies of all the wireless systems that are connected to it, you can get a lot. So like just looking at this diagram here, you have quite a few what look like ULXD quad receivers connected to a series of distribution systems. So what do we got? 4 times 4. Help me out. That's a lot of channels we got there on just 2 antennas. So it can be done. Just don't go overboard with cascading these distros because you can start adding noise into the system, and that can start to impact how your system works. So we usually just recommend cascading 1 additional system. So just keep in mind, if you're selecting antennas to cover a large system that has multiple frequency bands, make sure the antennas themselves can cover all of that range of frequencies. Cool. What do we got here? Oh, also, if you're doing this, obviously that goes to the point I just said. If you have a UHF system mainly, you're not going to be able to tie a VHF system into that same antenna system. In that case, you'll have to break that rule I said earlier and have multiple sets of antennas on the stage. And there's nothing wrong with that. Just don't put them close to each other. It's just best practice to have as few antennas as possible, and makes positioning them to get best line of sight easier and everything like that. Okay, let's look at some examples. These are going to be either good or bad. What do you guys think? Yes, this is bad.
So bad.
It's so bad. We stacked a bunch of those on top of each other, and all of those surfaces, those antennas are literally touching each other. So that's going to impact that system quite a bit. There's more things wrong with this, but I won't go into it because we're running out of time. I want you to have time for questions. Okay, if you look here closely, somewhere in the center, you can see the receive antennas. They are half waves. They probably are the right range for that receiver, but they are oriented completely straight out, pointing probably where they're, or if not, pointing away. So as far as, and also there's a metal chassis of another unit, right, basically touching them. So don't do that. That's bad. The next one, maybe there's some good ones in here. There might not be though. Good or bad? This is similar to the first one. That's obviously bad.
Yeah.
These are really tough ones. Okay, let's look at the next one. Okay.
I'm in this picture and I feel attacked.
So if you look at the bottom unit, that is a PSM 1000 transmitter with the antenna mounted right on the front, which is fine. But we have a ULXD quad receiver at the top with the antennas. I mean, what is that? 3 inches? So not only did we space these out more than a wavelength, but we have a system that's capable of outputting 100 milliwatts right next to a receiver that's looking for a very small fraction of that power by the time the signal gets from the microphone to the antenna. So we're basically blinding that wireless receiver. Yeah, there you go. That's bad. And sometimes you'll get away with it. If there's certain situations that might get away with it. Cheryl at least points her transmit antenna down and the receive antenna's up, I think. Is that right?
Yes.
So that might help. But if you ever have a bunch, what, you can say something? Sorry.
No, go ahead, please. Go ahead.
So I've run into multiple situations where they're like, we have clean frequencies. They look clean, but they're just dropping out. I can't get more than 20 feet from the rack before they stop dropping out. I have line of sight. Everything's right. And then usually the first question I ask is there in-ear monitors being used? Yes. Where are those? They're in the rack too. Where are the antennas? On the front. Okay. Turn those off, and then they check their range, and it works, 300 feet away. So think about things like that. Try not to do that. Again, if you have in your monitors, maybe think about getting a half wave antenna. If it's PSM 300, you can get a half wave UA8 just make sure you select the right frequency range to cover the frequency range for your PSM 300 system, and mount it up, use a 10-foot BNC, get it further away from the receive antennas, and that will probably clear things up. A directional antenna would be even better. Oh, excuse me. Sorry about that. Okay, let's keep going. Oh, I didn't put any good ones in there.
Don't do those and you'll be good.
We talked about how to do it right the whole slide, so I guess that should be fine. Okay, so what antenna should I pick? Putting it all together, if you're looking for wide coverage, like a wide area to cover, and the mic or receiver can go anywhere, omnidirectional or even the UA864 ceiling mount antennas would be a good way to go. If the antennas are farther from the transmitters, like let's say you're out at front of house and the stage is 7,500 more feet away, in those cases, look at a directional antenna like a LPDA like the UA874 or the PA805. Those would work really well for that because it will ignore other interference sources, a lot of multipath reflections, and it'll give you better range. Let's see. So the transmitter or receiver may frequently change orientation. That's where the helical antenna comes in. It kind of builds on the LPDA idea, but adds the circular polarization to it to help reduce the worry of, being 100 or 90 degrees out from your, or if one's horizontally oriented, the other one's vertically oriented. You don't have to worry about that with the helical antenna. Great for in-ear monitors and things like that, because some folks dance on stage, and that moves the antenna around a lot. What do we got next? So you need to reject unwanted interference, like the LPDA, because it's directional. Perfect. We'll just put the back of it at wherever our interference source is, if possible, or a helical antenna would work in that case too. Omnidirectional antennas obviously accept a signal from any side of it, so try to stick with a directional antenna if possible. And then if you're close to where the transmitters are being used, there's no need to use a directional antenna. Let's say if the gear's on the side of the stage, you can very well use the included quarter wave antennas as long as you're following the other rules. And use, if you have intended distribution, use that. Just use 2 quarter wave mounted to the chassis will be a good ground plane on the side of the stage, all good. Or use half waves if you need to get them up a little higher, if you need to remote mount them like the UA8. And one thing I forgot to cover is the A and B antennas on our wireless microphone systems don't have to be the same. If you think it'll benefit you to have a helical on one and a UA8 Omni on the other, cool. It's not going to just not work because of that. All right. I think we're good. Okay, so if you take a screenshot real quick, this is a really good chart to kind of give you an idea of all the specifications for our antennas, along with the last slide. It's really helpful information. You have your half waves, your wideband half waves, the UA860, the UA864 wall or ceiling mount antenna, the LPDA, which would be a PA805 or the UA874, and then the helical antenna. So going back to what we've talked about, depending on your application, any of those antennas might be the best choice. For some of you who have a very versatile setup where you can use the antennas that best fit the event, awesome. Okay, and then here we have some online sources, resources. We have a really good documentation, the wireless, here, let me move this, wireless setup guide. It's an amazing, just make sure you read through it a few times, but it ends up being super helpful. Wireless accessory wizard on our website is one of my favorite tools that I use all the time, especially if you're trying to build a wireless system or you're not sure. It'll help you decide what is the best way to go as far as building out the antenna distribution and selecting the antenna, the antennas themselves. There's a remote mic antenna tool, so if you're not sure if the antenna that you want to select is going to be usable depending on how long the antenna cable run and everything is, it'll tell you what you would need as far as amplification and stuff goes, depending on the cabling that you use and how long it is. And then a newer tool is a link budget calculator. If you're putting together a more complex system and you want to make sure your gain from beginning to end is going to be at a usable level, that's a great tool to check out. All right, questions. Sorry, I went a bit over there. Sorry, Cheryl.
That's okay, Jim. It's good to have all this great information. Let me stop sharing here and let me get my questions over. We got quite a few questions. I know we're a little over time, but Jim, are you good to answer a few of these?
Yeah.
All right, great. And for those of you that have to drop off, we'll make sure to include these questions in the recorded version. So if you have to drop off, we'll make sure they're there. Okay, let's see. First question. For directional shark fin antenna, you say each dipole is optimized for particular frequencies and bands. What drives the selection of the internal dipoles? Are they all connected electrically, in which case do all the dipoles get the same signal and ultimately performance is the result of at least one dipole optimally transmitting the appropriate frequency? Wow, that was a mouthful. But you were nodding, so I think you got the question.
Yeah, so it is a series of, and they're all driven. Unlike a Yagi would have a single driven dipole element with a few directors and a reflector. The LPDA is a bit different, where all the elements are driven, and they're arranged out of phase from one each other. So I'd have to. I wish I had one here to show you a little bit better. But yeah, the size, because they resonate at the frequency that you're transmitting on, they end up you don't obviously you don't have to do anything as far as the antenna just works the way it's designed well, and the particular elements in there are used looking at that heat map depending on which frequency is being received or transmitted. It's just the way that the sizing and the resonance of them and the frequency wavelength being used.
Okay.
Oh.
And I'm going to jump to a later question because it kind of is applicable and it's something that we should probably answer sooner rather than later. What does LPDA actually stand for?
Log periodic dipole array.
I feel smarter. All right. What is the left-hand wound and right-hand wound antenna, and why should I care?
Most of the time, you wouldn't care. You could get away with just selecting a left hand or right hand wound, but if you're doing an A and B, just make sure they're the same. And if you had in-ear monitors, you could do the opposite to kind of help. But if they're all on one side of the stage facing away from each other, you probably wouldn't have to care. You could use all three of the same wind, but you could use that to your advantage in certain situations.
Great. Is the UA860 considered waterproof or
No.
weatherproof? No.
No, unfortunately, none of our antennas are weatherproof. You would have to, I'd end up looking at a weatherproof antenna if you're selecting that, or you can get acrylic housing to, encase it. And you got to think about the cabling too, is there's the B and C connection on the bottom that are exposed and can become corroded over time. So try to not put them out in the elements without any kind of protection.
Okay. I have somebody asking about just kind of about the whole not using amplified antennas for in-ear monitor systems. So maybe you could talk about that. And in their example, they have their in-ear transmitters at the front of house. And of course, the in-ear receivers are on stage. So what would you advise for dealing with that?
If you're doing that, depending on the transmitters you're using, I would, if you're going from front of house to the stage, see if you can bring up the RF output power if you're getting poor reception, but don't bring it up more than you need. Don't just crank it up all the way from the get-go. If you set it to 10 milliwatts and you have excellent reception and no issues, just leave it there, because that's going to raise the noise floor all around, and even your intermodulation products from multiple transmitters is going to be raised as well. So you got to be careful with that. And as far as the amplification goes, for in-ear monitors, you want to be very careful, because you could easily make your system not legal to operate if you're using amplification on your transmitters. So try not to do that. In our equipment, all of our amplifiers only work in one direction. The circuitry doesn't allow the signal to go in both directions.
And there it is. Okay, next question. In divisible conference room applications, as in like 3 rooms that can be opened into one single giant room, is it best practice to use a UA864 for each room, or could you cover multiple rooms with one remote antenna with the rooms closed?
So if the rooms are closed off, you always want to be, especially with wireless microphones, you would want an A and B antenna nearby. You always want to be able to have this. So you wouldn't be able to put an A antenna in one room and then a B antenna in the other room unless you know like the air wall is really transparent as far as wireless frequency goes. So in those situations, we have really good articles on our website. If you go to the website and click in the little search bar in the top right and just type like 2 zones, 4 antennas, there's a diagram and explanation of how to do it. And it usually comes down to just basically combining the sets of A and B antennas, multiple ones from each room before hitting the receiver. So you still just have one A run and one B run coming from overall. There's also solutions that provide like multi-zone antenna setups where you can home run all of them. But it really depends on how your cable runs would be when it comes to choosing the right parts. That's more of an advanced topic that'll probably be covered by another webinar. Sorry.
No, no worries. All right, next question. The screen is a little small for me, so bear with me as I squint to read this.
Yeah.
Hi, is there any issue using an HDSDI 75 ohm for a standard deployment of an active directional UA874 transmitter from cascaded devices from a UA844 plus? And if so, what is the length limitation of the run? In mind for an upstage I/R deployment, large deck, not front of house, trying to resolve a dispute. Cheers.
Okay. So I think is the question basically, can I use 75 ohm cable for my?
I believe so, yes.
Okay, well I'm sorry I didn't mention that all of our wireless components and antennas are 50 ohm. So with a lot of video cable out there, they are 75 ohms. So when you are selecting, if you, for whatever reason, have to use a 75 ohm cable, it's not going to completely destroy your system, but there will be impedance mismatches. And every time you do that, you essentially get around 2 dB of loss. For every time you go from 50 ohms to 75 ohms or 75 ohms to 50 ohms, you're going to get loss. And you basically will want to calculate and make sure you're not, more than 5 dB of loss by the time you get to the receiver. So you can do it. It's not advised. Just make sure the cable you're using, like let's say you're using RG6, that's a pretty good low loss, inexpensive, very abundant 75 ohm cable. As long as you use the amplification if needed to compensate for the loss that you'd have with the impedance mismatches and the loss over the cable run itself, you should be fine.
Okay.
I wonder how the
Next question.
dispute went.
I hope you helped. All right. Next question. You mentioned that Shure systems with 2 antennas are for diversity A and B to enhance reception of signals, but aren't
Mhm.
the 2 antennas on a PSM 1000 transmitter for the 2 separate channels within, one antenna for each of the 2 channels? Thanks.
Yes, good question. So all of our wireless microphone receivers will have an A and B antenna, but our in-ear monitoring systems only have one transmit antenna. With a P10T, which is the dual transmitter, there are two B and C connections on the back, and that is a send for each channel, not a diversity setup. But the PSM 1000 body pack, which is the receiver, the P10R Plus, has 2 antennas on it. I don't have one with me, and it is essentially a diversity setup for the receiver. Sorry about that.
Okay. Next question. I understand basically at least how diversity antennas work and why they should be at right angles to each other. Why don't operators put LPDAs at right angles? Ignorance, or is there an actual reason?
Oh, that's a good question. You can totally, because those are polarized similarly to where an LPDA, if it is vertical, it is the wave is going to be vertically polarized as well. So you can do the same thing. That does not just apply to the omnidirectional antennas. You could do the same thing for the LPDAs and get a similar result.
Okay,
And
awesome.
that'll help with the diversity and your polarization, any problems that might cause. So,
All right.
good question.
Was the paired positioning 6-inch separation between the receiver antennas a recommendation set, or simply a minimum, or is a larger spacing offset preferred?
A larger offset's preferred. I think what is usually said is a wavelength. So a wavelength, if this was a half a wavelength, that would be, I guess you could do a half wavelength, would be about a foot for UHF. So more is going to be, any more distance is definitely going to help as far as your diversity setup goes. But you wouldn't want to go too much. Anything over like 10 feet is probably not going to add any benefit to having separation for your antennas. But I think I'd say at least a half a wavelength, and you shouldn't have to worry about it as much.
Great. And then when you talk about long cable runs, like what would you consider a long cable run? Is that anything over 25 foot, 50 foot? What's the
It depends
starting?
on the cable you're using. So RG58, I think over 100 foot is somewhere around 20 dB of loss, but an RG213, which is what our 100-foot lengths are made out of, is around 6 dB of loss. So it just depends. If you're using an RG58 for a 50-foot run, that's going to make a big difference over having like an RG213, an LMR 400, or an RG8. So it really depends. That's where it comes to calculating it. You'd want to look at what type of cable you have, and you could use that link budget calculator. There should be different options in there for making a custom cable, where you could basically say what kind of cable you have, how long it's going to be, and it'll tell you how much loss there's going to be. And you want to be within, plus or minus 5 dB by the time you get to the receiver.
All right. I know you mentioned this when we saw the chart, but I'll just ask it again so we can reiterate it. Can external antenna pairs be a mixed type, as in one directional and one omni, or one active and one passive?
Yes, they can be mixed. They do not have to be the same. I'm thinking right now. I probably should have mentioned this, and I'm sorry. They don't have to be the same. We're covering that, but I just thought of something important I should mention. Especially when it comes to our active antennas, they require a voltage over the B and C to operate. There's not like an external power supply for those equipment. So if you just have one receiver, make sure the receiver itself provides that voltage. You usually say like 12 volts DC by the B and C on the back. But if it does not provide that voltage, the amplifier won't work and it will cause a lot of problems. You just won't get any range at all, basically. So make sure if your receiver does not have that voltage, which like BLX, QLXD, SLXD does not have, we have a UA bias T, or UABIAST is basically a little DC injector. Okay, covering that. Sorry. But yeah, as long as your receiver can support the antenna you're connecting to it, they do not have to be the same. You could use an Omni in theory to cover something really close by, and then use the like a directional antenna pointed at the furthest place in the room that the microphone would go, and that would work fine.
Okay. Great. I think you touched on this, but what is the minimum recommended distance between two UA874?
It'd follow that same rule, at least a wavelength. I think about 10 feet is usually what people would do, but it really depends on the area you have as far as placing, because not all stages or front of house booths have just unlimited space to space out these antennas. So I would say at minimum of wavelength to be safe.
Okay.
Which would be about a foot, or that would be a half. So about 2 feet would be fine.
Great. Should you always place paddle antennas behind helical antennas?
It doesn't matter as far as which one's a helical and which one's a paddle. It's more which one is transmitting and which one is receiving. So if you had two receive antennas and a transmit antenna, you could put the transmit antenna in front of your receiving antennas if it's directional too. Or you could do the opposite. Let's say for your in-ear monitors, you had an omnidirectional antenna, and your wireless microphone systems, you had directional antennas. Then you could put the omni IEM antenna behind the paddle antennas for the receivers, just so you're not just using the directionality of that to your advantage. But
Okay.
helical versus LPDA is not as big a deal.
Okay. Now I know we talked about this, but I think there was a little confusion from one person. Is the helical antenna omni? Because in the chart it says directional. The helical is actually a directional antenna, correct?
Yes,
Yes.
it's a very directional antenna. So between 60 and 75 degrees as far as the transmitter receiving pattern would go. If we go back to those heat waves, heat wave, those heat map slides, it gives you a good idea of that.
Okay.
But helicals are very directional.
Next question, are there any resources for I'm going to take this one, a more thorough hands-on or hands-on basic introduction to Shure wireless systems and best practices that can be attended? We do have the Shure Audio Institute, which kind of hosts and manages these webinars, has a whole other host of both online and in-person training options. So if you go to Shure, I think it's shure.com/training. I could be wrong about that. Or if you even go to the shure.com/webinars page, you can kind of back out into the SAI and SAI pages and see what they have available. They do have a wireless master class, which is fantastic and in-person and hands-on. Those have not happened frequently in the past couple of years for some reason. I think we all know what that reason might be, but those will be picking up again. So go to shure.com/training and you can learn all about the Shure Audio Institute. There's a lot of great resources and tools there. Tons of webinars, tons of online modules and things like that. So lots of good stuff there.
Here, here.
Okay, let's see. I'm just gonna try and maybe pick some important
Here, let me
ones.
do a plug too. If you need immediate assistance or you just aren't sure after going to SAI and things like that, call into the Shure Applications Department because I'm in there and we have a lot of really smart folks who can help you out in there as well.
Yeah, and I will also piggyback onto that and say you can also go to shure.com/contact. If you go to that website, shure.com/contact, you can open up a ticket with that same team. Jim works on that team. There is a great group of applications engineers that can answer so many questions. I know I have bugged many of them over our office chat many times with my little questions in the past. There are a lot of extra questions, but we are way over time. So I'm sorry if we didn't get to your question. If it's really burning a hole in your brain, go to shure.com/contact. Fill out that form. Our applications engineers will answer it for you. We want to thank you so much for joining us. Jim, thanks for all the great information. And I know I have some antenna setup work to do on my rack, so I'm going to go take care of that shortly. Have a great day, everybody, and we'll see you on the next one.